Hello everybody, this is Professor Yogesh and today we are going to discuss about the lab exercise 3 of Digital Design and Computer Organization lab. So in lab 3 exercise, we have the program on designing a Verilog HTL program to implement a simple circuit using the various styling models. So it could be a structural, data flow or behavioral model. So for the example sake, I have taken 1-bit comparator. So for 1-bit comparator, we have two inputs A and B and three outputs, which is A greater than B, A less than B, and A equal to B. So this is the circuit of 1-bit comparator, and we are supposed to provide two inputs called A and B, which are 1-bit in nature. And to the right hand side of it, we have a truth table where we have two inputs. So possibly four combinations we can give 0, 0, 0, 1, 1, 0, and 1, 1. The first and the last condition gives the output for A equal to B, and the second condition gives the output for A less than B, and third condition gives the output for A greater than B. Right. So the expression for this would be for the A equal to B condition. So we have 0 0 and as well as 1 1 condition here. So when both are same, when both the inputs are equal, then only we have the output condition for A equal to B condition. So if you look at the output pattern, so 1 0 0 1, it resembles the NOR gate output, sorry, XNOR output. So in order to write the expression of XNOR output, I should go by NOT of XOR. So A equal to B should be equal to NOT of XOR. Similarly, for A greater than B, so we can write the output expression as A and not of B. And similarly, for A less than B, it should be not of A and B. So this is the application part of it. Now, when we go to the programming part of it in data flow description, so we have a program written in the module name of COMP, which is comp. So I'll directly go to the tool. So the tool is Xilinx tool. So you can see here in the Xilinx tool. So we have already created the data flow structure here. So the module name is COMP here, and the input arguments are A and B, and the output arguments are A greater than B, A equal to B, and A less than B. So we have defined them as input and output here, right? And to assign them, as I've already said, based on the expression, whatever we have from the truth table. So I've assigned the expressions for A greater than B, A less than B, and A equal to B. So A and of not of B is A greater than B, and not of A and B is the expression for A less than B, and not of A XOR B is the expression for A equal to B. So this is the program written for a simple circuit of 1-bit comparator using data flow structure. And to see the output of it, we should run this exercise. So I am running the exercise here. So I'm compiling it by making use of a implement design. So if I compile it, I'll get to know whether the code has got any syntax error or not. So it is getting executed now. If there are no errors, then the compilation will be successful. As you can see here, the process generate post place and wrote static timing completed successfully. So this indicates that there are no syntax error in the application. Now in order to run this, we should provide a test bench. So in order to provide a test bench, we should go here and add the test bench. I have already added the test bench here. So I'll go directly to the test bench. So the test bench program for it is this. So where we declare the input parameters as registers and output parameters as wire. And we have to instantiate the unit under test with the main program. So all these A of A, B of B, and output parameters are declared to correlate with the values that are given here with the main program. So the main program values, whatever we have here, should be correlated with the test bench values. So for that, we have to instantiate the unit which is under test with the input and output values. And in order to provide the data for A and B, so this is the values that has been assigned: A equal to 0, B equal to 0, 0, 1, 1, 0, and 1, 1. Right? So the value has been given. And again, in order to check the syntax, so we have to select the test bench here and then check for syntax. So if the syntax is correct, you can get the message something like this: successful syntax check error as a syntax check condition. And once the syntax check is successfully completed, go for behavioral simulation. So when you simulate it, you will get the output pattern something like this. Use the margin here to see whether the outputs are in line with the input values. So now you can see the left hand side, which I am marking the uh, input and output here. So the output is 1 here for A equal to B, because input A and B both are 0 0 here. Now for the second condition, A is 0, B is 1. So which means A is less than B. So for A is less than B, we have 1 here. So the output is A is less than B. Similarly, for the third condition, A is 1, B is 0, and it says that A is greater than B. So the output for A greater than B should be 1. So you can see here it is 1. And lastly, when both the values are again 1, which means both are equal, so we have the output for A equal to B condition. So this is the output for a simple circuit of 1-bit comparator by making use of a data flow modeling style. Thank you so much.